This video provides detailed answers to questions from the Cambridge IGCSE Paper 2 Extended, May-June 2024. I hope you find it useful in helping you prepare for future exams. In addition, on this channel I have prepared lessons on each subject. Happy studying! Thank you in advance for watching this video. If you like it, please like, subscribe to the channel, share the video and activate the bell icon. This is very important for the continuity of this channel. Question 1. The diagram shows two sides of a parallelogram ABCD. Find the coordinates of point D. In a parallelogram, the opposite sides are both parallel and equal in length. Given points A, B, and C, we need to determine point D such that line segment AD is parallel to and equal in length with line segment BC. This means that the changes in the x and y coordinates from point B to point C must be the same as the changes in the x and y coordinates from point A to point D. First, you calculate the changes in the x and y coordinates from point B to point C. The x coordinate changes from -1 to 3, resulting in a change of 4. For the y coordinate, it changes from 1 to 3, leading to a change of 2. Next, you apply these changes to point A. You add the change in the x-coordinate and the change in the y-coordinate to the coordinates of point A, which are -7 and 5. This gives you the new coordinates for point D. X-coordinate -7 plus 4. Y-coordinate 5 plus 2. Therefore, the coordinates of point D are -3 and 7. Question 2. Geetha has a box of toys. She picks a toy at random from the box. The probability that she picks a wooden toy is 0.6. Item A. Work out the probability that she does not pick a wooden toy. The sum of probabilities of an event happening and not happening is 1. If the probability that she picks a wooden toy is 0.6, the probability that Geetha does not pick a wooden toy is 1 minus 0.6. Item B. The box contains 3 types of toys: wooden, plastic, and metal. Complete the table. There are several ways to solve item B. One straightforward approach is to recognize that if the probability of Geetha not choosing a wooden toy is 0.4, and there are equal numbers of plastic and metal toys, then the probabilities of her choosing a plastic toy and a metal toy are the same. Therefore, the probability for each of these choices is 0.2. Let's denote the number of wooden toys as x. Therefore, the total number of toys can be expressed as x plus 28. To calculate the number of wooden toys, you can use a simple proportional relationship. If x plus 28 corresponds to 1, then 28 corresponds to 0.4. You now need to solve the equation for the variable x. Question 3. The table shows some information about two sequences. Item A. Complete the table. To calculate the fifth term in both sequences, you must replace n with 5. Item B. Find the smallest positive number in sequence B. To find the smallest value of n such that n squared minus 300 is positive, you need to solve the inequality. Taking the square root of both sides gives you approximately 17.32. The smallest integer greater than 1732 is 18. Therefore, you replace n with 18 in the formula to find the required number. Question 4. Find the greatest odd number that is a factor of 140 and a factor of 210. To solve this problem, we can use prime factorization. If you want to learn how to calculate the highest common factor of two numbers, be sure to watch the video in the upper right corner of the screen. In this explanation, I will use the simultaneous factorization method to find the highest common factor of 140 and 210. We begin with 2, the smallest prime number that divides both numbers evenly. Since 2 is a common factor of both 140 and 210, we will mark it with an asterisk. Dividing both numbers by 2, we get 105 and 70. The prime number 2 divides 70 completely, but it does not divide 105. Therefore, we will not mark the prime number 2 since it is only a factor of 70. Dividing 70 by 2 gives us 35. So we will place 105 next to 35. Now neither 35 nor 105 is divisible by 2. So we move on to the next prime number, which is 3. The number 3 is a factor of 105, but not of 35. Thus, we will not mark prime number 3 either, as it is only a factor of 105. When we divide 105 by 3, we get 35, and we will place this value next to the existing 35. Since 3 is not a factor of 35, we proceed to the next prime number, which is 5. The number 5 is a factor of 35, so we will mark it with an asterisk. Dividing 35 by 5 gives us 7. We know that 7 is a prime number and can only be divided by itself, so we will also mark 7 with an asterisk. Dividing 7 by 7 results in 1. Since we have reached the quotient of 1, we will stop here. In my opinion, this method is very useful for calculating both the least common multiple and the highest common factor at the same time. The least common multiple is determined by multiplying all the prime factors together, while the highest common factor is found by multiplying only the common prime factors, which are marked with an asterisk. I did all this to remind you of the highest common factor and the lowest common multiple. But we could have stopped at the fourth line because we can see that the greatest odd number, that is a factor of 140 and a factor of 210, is 35. Question 5. Calculate. To solve part A, calculate the cube root of 343 and the square root of 40.96. Then subtract the two results. To solve part B, first add 192 to 64. Then calculate 256 raised to the power of 1.25. Question 6. The diagram shows 5 kites that are congruent to kite ABCD. Each kite is joined to next kite along one edge. Angle DAB equals 40 degrees and DCE is a straight line. Find the value of x. Let's begin by noting that the sum of the angles around point C is 360 degrees. Since all 6 kites are congruent, we can denote the angles around point C that are interior to the kite as theta. Therefore, 6 times theta is equal to 180 degrees, which gives us the value of theta as 30 degrees. We observe that angle ADC is equal to angle ABC. Next, knowing that the sum of the interior angles of the kite is 360 degrees, we can express this relationship mathematically. X plus 40 degrees plus 30 degrees equals 360 degrees. Now we just need to solve this equation to find the value of x. Question 7. The diagram shows a shape made from a triangle JKAL and a semicircle with diameter JL. JKL is an isosceles right triangle with JK equals JL equals 12.8 centimeter. Item A. Calculate the area of the shape. This exercise asks you to calculate the area of a shape made up of an isosceles right triangle and a semicircle. You will first calculate the area of the triangle and then the area of the semicircle, adding both areas together for the total. The diameter is always twice the length of the radius, or d equals 2 times r. So you must first determine the radius. The area of a semicircle is calculated as half the area of a full circle. In short, to find the area of a semicircle, divide the area of the full circle by 2. Next, calculate the area of the triangle. The area of a triangle is equal to half the product of its base and height. The total area of the shape is the sum of the area of the triangle and the area of the semicircle. Item B. Calculate the perimeter of this shape. Item B asks you to calculate the perimeter of the shape. The perimeter is the total length of the boundary of the shape. For the semicircle, remember that its length is half the semicircumference of a full circle. Next, you will need to calculate the length of the leg KL in the right triangle using the Pythagorean theorem. Finally, calculate the perimeter of the shape. Question 8. These are the first 5 terms of a sequence. Find an expression for the nth term of the sequence. To solve this exercise, begin by calculating the common difference. The difference between consecutive terms is as follows. 18 minus 11 equals 7. 25 minus 18 equals 7. 32 minus 25 equals 7. Therefore, the common difference is 7. Since the sequence has a common difference, it qualifies as an arithmetic sequence. The first term is 11, and the common difference is 7. Substitute these values into the formula and then simplify it. Question 9. The value of a car is $8,000. Each year the value of the car decreases exponentially by 25%. Calculate the value of this car after 3 years. The value of a car after several years, given its initial value and the annual depreciation rate, can be calculated using the exponential decay formula. Apply this formula to determine the car's value after 3 years. Question 10. Amir invests $1,500 in an account. The account pays compound interest at a rate of R% per year. At the end of 8 years, the value of his investment is. Find the value of R. This exercise requires you to calculate the interest rate for a compound interest account. The formulas for compound interest and exponential decay are similar. Simply replace the minus sign with a plus sign. So plug the given values into the compound interest formula to find the interest rate. Take the eighth rule of both sides. Question 11. Find the inequalities that define the unshaded region R. To identify the inequalities represented by the shaded regions on a graph, you need to find the equation for each line on the graph. Vertical and horizontal lines have simpler equations, such as y equals k for horizontal lines and x equals h for vertical lines. To find the equation of a sloping line, you must determine the slope and the y-intercept. On the graph, you can see that y must be between 1 and 5. You must use the less than or equal to sign because a solid line indicates that the line is included in the region. X must be less than 6. A dotted line indicates that the line is not included in the region. For y equals x, the shaded region is below the line, and the line is dotted, so the inequality is y is less than x. If you are unsure whether the last inequality is correct, verify if by substituting the coordinates of the shaded region. For instance, consider the point with coordinates 5 and 3 marked on the graph. Since 3 is less than 5, this confirms the inequality y is less than x. Question 12. Solve the simultaneous equation. You must show all your working. There are three methods for solving simultaneous equations: the elimination method, the substitution method, and the graphing method. Regardless of which method is used, each one will yield the same solution. However, some methods may result in simpler calculations depending on the specific equations. In this case, the elimination method seems to be the most efficient. To apply it, multiply the second equation by -3 and multiply the first equation by 8, and then add the two equations together. After finding the value of y, substitute it back into the second equation to determine the value of y. Question 13. The diagram shows a cyclic quadrilateral. Find the value of p. A cyclic quadrilateral is a four-sided figure whose vertices all lie on the same circle. In a cyclic quadrilateral, the sum of the measures of the opposite angles equals 180 degrees. First, you need to calculate the value of m, and then you can calculate the value of p. Question 14. The diagram shows a circle with radius 9 centimeters. Calculate the area of the shaded major sector. To calculate the area of the shaded major sector, you first need to determine the angle of the major sector. This angle is found by subtracting the angle of the minor sector from the total angle of the circle. If you are familiar with the formula for calculating the area of a sector with a central angle theta, you can use that. However, if you are not, you can solve this problem using direct proportionality. The area of the entire circle is given by the formula pi times r squared. Therefore, the relationship can be expressed as p times r squared corresponds to 360 degrees, as the area of the sector corresponds to 312 degrees. Now you can solve the proportion to find the area of the shaded sector. Question 15. Writing the recurring decimal as a fraction in its simplest form. You must show all your working. Recurring decimals can be converted into fractions by setting up an equation and solving for x. Let x represent the recurring decimal. First, multiply x by 10 to shift the decimal point one place to the right. Next, multiply x by 1000 to shift the decimal point 3 places to the right. Finally, subtract the first equation from the second to eliminate the repeating part of the decimal. Solve for x and simplify. Divide both sides by 990 and then divide both the numerator and denominator by 5. Question 16. A. In the Venn diagram, shade the region representing the intersection of the complements of set M and set N. Item A asks you to shade the region representing the intersection of the complements of set M and set N. The complement of a set M denoted as M prime is the set of all elements in the universal set that are not in M. The complement of a set N denoted as N prime is the set of all elements in the universal set that are not in N. The region representing the intersection of the complements of set M and set N is located outside both circles M and N in the Venn diagram. Item B. Find the number of elements of the set. First, write the complement of set A, then write set C. Next, determine the union of these two sets. After that, write set B and find the intersection of set B with the union of set C and the complement of set A. Finally, calculate the number of elements in the resulting set. Question 17. Calculate the area of triangle ABC. The area of a triangle is given by half the product of the lengths of two sides of the triangle times the sine of the angle between the sides. Question 18. The diagram shows the graph of a cubic function. By drawing a suitable straight line, solve the equation. To solve the equation graphically using the provided graph of the cubic function, you need to plot the graph of y equals 2 times x and identify the points where the two graphs intersect. Each intersection point represents a solution to the equation. To draw the line y equals 2 times x, find 2 points on the line. Upon carefully examining the graph, the intersection points are approximately minus 0.5 and 0.89. These values are your solutions. Question 19. Factorize completely. Item A. To factor an expression, find the highest common factor of all the terms and write it outside a set of parentheses. The missing terms in the parentheses are obtained by dividing each term by the highest common factor. To factor the given expression, identify the highest common factor of 12 and 75, which is 3. Write 3 in front of the parentheses and divide each term by the highest common factor to determine the missing terms inside the parentheses. The expression inside the parentheses, 4x squared minus 25t squared, is a difference of squares. Apply the difference of squares pattern to obtain the fully factored form. To solve item B, rearrange the terms and factor by grouping. Rearrange the terms to group terms with common factors. Group the first two terms and the last two terms. Factor out x in the first and 3 in the second group. Notice that y plus 5 is a common factor. Factor out the common term y plus 5. Question 20. Solve the trigonometric equation. We need to solve the equation for sine of x. Once we have sine of x, we need to find the angle x within the range of 0 degrees to 360 degrees. To do this, we use the inverse sine function on a calculator set to degree mode to find the reference angle in the first quadrant. It's important to note that the sine function is negative in the third and fourth quadrants. Therefore, to find the angles in these quadrants, we can use the following formulas. In the third quadrant, the angle is calculated as 180 plus reference angle. In the fourth quadrant, the angle is calculated as 360 degrees minus reference angle. If you want to learn more about trigonometric equations, you can watch the video that appears in the top right corner of the screen. Question 21. The diagram shows a cuboid. HD equals 4 centimeters, EH equals 6.5 centimeters, and EF equals 9.1 centimeter. Calculate the angle between CE and the base CDHG. To solve this exercise, create a right triangle with vertices CE and HE on the base CDHDG. In this triangle, the segment EC is the hypotenuse, while the segment HC represents the length of the diagonal of the rectangle CDHG. Note that the diagonal HC is also the hypotenuse in the right triangle HDC. First, use the Pythagorean theorem to calculate the length of the diagonal HC. Next, using the tangent function, you calculate the angle between EC and the base CDHG. Question 22. Bag A and Bag B each contain red counters and blue counters only. Stefan picks a counter at random from Bag A and Jan picks a counter at random from Bag B. The probability that Stefan picks a red counter is 0.4. The probability that Stefan and Jan both pick a red counter is 0.25. Find the probability that Stefan and Jan both pick a blue counter. The problem provides the probability that Stefan picks a red counter, as well as the probability that both Stefan and Jan pick a red counter together. To start, remember that the probability of two independent events occurring simultaneously is calculated by multiplying their probabilities. Since Stefan's and Jan's picks are independent, the joint probability of both of them picking a red counter is the product of their probabilities, which allows you to find the probability of Jan picking a red counter. Additionally, the probability of picking a blue counter is the complement of picking a red counter. This means you can also determine the probabilities of Stefan and Jan picking blue counters. Again, since their choices are independent, the probability that both Stefan and Jan pick blue counters is the product of their probabilities. The probability that both Stefan and Jan pick a blue counter is 0.225.